Welcome back. I'm Professor Steele, and we are now going to develop one of our laws for our triangles. Up till now, we've discussed right triangles, where there is one right angle in the triangle. But we do have triangles that are acute, where there are three angles between 0 and 90 degrees. And we have also obtuse triangles where at least one angle is between 90 and 180 degrees. What we are going to look at is an oblique triangle. An oblique triangle has angles that are between 0 and 90, but there are no right angles. So here is our triangle, ABC. If you remember the way we label our triangles, our capital letters are for our vertices, and opposite those angles, we use a lowercase to signify the side. So this would be side A, this would be side B, and this would be side C. Now, if you notice, because this is oblique, we don't have any right triangles. However, we can create them. So if we drop what we call a perpendicular, we now have this length is still A. We have a height, and we don't know what this piece is or this piece, so we can call this X, and this portion is now A minus X. So far we've just labeled our oblique triangle with measurements. So let's look at different triangles in here, since these are both right angles. Looking at the right triangle, so triangle, we can call this D. In triangle ABD, we have the height squared plus this length squared equaling C squared. So there's one relationship we have. Similarly, on this side, we have in triangle ACD, we have H squared plus X squared equaling B squared. So far we have a relationship between all the components of our right triangle. Now what we're going to do is somehow use this piece of information so we can find a relationship between the three sides, A, B, and C. So if we look at this particular equation, if I want to isolate my H squared, which would give me C squared minus A minus X squared, I can take that and replace the H squared in the second triangle with that entire quantity. So we have C squared minus A minus X squared plus X squared equaling B squared. Not too bad. We still have a little bit of unknowns here. So let's expand this. We have A squared minus 2AX multiplying by a negative, which is plus 2AX plus X squared times a negative. And what do you notice happens? Our negative X squared and our positive X squared simplify to 0. So we are left with C squared minus A squared plus 2AX equaling B squared. So we're very close to where we want to be. The question is, can we somehow write X so that replace X with a quantity that we might know? At this point, we need to find a relationship between X and possibly other pieces of this triangle. If we look at what we've been given, remember, H is also an unknown, so we try not to use that. If I focus on this triangle, cosine of C would be the adjacent side over the hypotenuse side, X over B. If I isolate X, that gives me B cosine of angle C. So I'm going to take that value of X, B cosine C, and replace it right here in place of our X. So our line becomes C squared minus A squared plus 2A B cosine C, and this is equivalent to B squared. So we have now found a way to figure out a side as long as we know one of the angles. Now, here is the piece that's important. What we have, if I can leave my C squared by itself and bring everything to the other side, we have C squared equals A squared plus B squared minus 2AB cosine C. This is what we call our law of cosines. So take note. If I would like to find the measurement of one of my sides, what I need is the measurement of the other two sides and the angle corresponding to the missing side. Looking at our final product, that missing side is c squared. We need to know the a squared and the b squared, the other two sides, and we need to know the angle opposite that side. And obviously the a, b's, and c's are interchangeable. This could have been a squared equals b squared plus c squared minus 2bc cosine a, and alternatively with the third angle. Thanks for watching. Please like and subscribe to EdVantage. We'll see you next time.